Hi, in this video we will review the notion of one-to-one functions. We will see why do we need these functions and how we can check if a function is one-to-one or not. Let us recalling the definition of a function. A function is a rule which to every element x in the domain, this domain is a set, so for every element in the domain it assigns a unique element f of x in the range. So in other words, when you have a function, two sets are involved, set of all possible inputs for f, so all possible x's, possible values of x, and well, there is all possible values of f, so that's called range, so all values of f. And function f goes from the domain to range, sending every element x to a unique element y in the range, while to show the dependence we show it by f of x. It means that it depends on x. So this is the definition of the function, but our goal here is we like to find the reverse assignment, the reverse rule. So we like to find the reverse assignment. What does that mean? It means that that is, we want to find another function such that to every y in the range of the function, in the range of f, assigns to every element in the range of f assigns x in the domain, in the domain of f, such that, well, before x was sent to y, now this new assignment we want to reverse this thing such that f of x is exactly the value. So if before x was sent to y, this is x sent to y, we are looking for an assignment which does this thing, reverse this assignment, sends y to x now. Well, this is very nice idea, but we right away, almost at the beginning, we see there is a big issue. And the issue is that sometimes we have more than one x, well, x1 and x2, which are assigned to the same element y in the range by f. It means that, well, sometimes you may have cases the function f sends two different elements to the same element, so x1, x2. Well, what is the issue with this thing? Well, if you want to find reverse of this assignment, now you don't know, are you going to send y to x1 or x2? How are you going to define the inverse assignment or the reverse assigning for y? And well, there is no way to choose that. So that makes the reversing brings up a big issue with the reversing of the functions. Well, then the solution for this thing is that ignore all functions which have that property. So exclude all functions which have that issue. Well, the remaining set of function is what we call one-to-one functions. Okay, so then let me just write the definition. So this is where the one-to-one functions come in. So definition: a function f is called one-to-one if this happens, that if x1 and x2 are different, you can see that their values will be different for all x1 and x2 in domain of f. So we don't like to have cases like this. So we only want to study one-to-one functions, which means that if x1 is not equal to x2, their functions, their values, the values of the function at those points are different. So this is the definition, but in practice, there's a nicer way to check if the function is one-to-one or not. So algebraically, what is usually better to check is that we use an equivalent form of this definition. It says that, well, set f of x1 equal to f of x2. If all x1 and x2 different values gives you different values of f, so if two numbers have the same value, the function has the same value at two numbers, then you have to be able to conclude that those two x1 and x2 are same. So this here use the definition and so on, use the definition of f and try to prove this thing. So this is algebra. I will show you in an example, but there's also a geometric, very nice way of checking this geometrically. So it is called, this is what so-called horizontal line test. Horizontal line test. It checks for us if a function is one-to-one or not. A function is one-to-one if and only if every horizontal line intercept with its graph, with the graph of f at most once. Well, if you have a graph of a function, something like this, or maybe another one here, so when you draw all the horizontal lines, it at most intersect once with this graph. Well, while in this case, if you draw a horizontal line, you see horizontal line means that intersection of horizontal line with the graph means that these are the values of function for values of x for different values of x. So there's x1 here, x2 here, x3 here, that all of them gives us the same y or same value of the function. So this fails. This is 1 to 1. Okay, let's finish video with some examples. Determine which one is 1 to 1 function. Use both tests if you like. Well, any way you can use. So for example, the first one is function f of x equals to x squared. Okay. The second one is f of x equals to 2x plus 1. The third one is f of x equals to e to the power x. Fourth one, this is sine x. And well, this last one, this is a good example. Basically shows everything algebraically very nicely. Okay, this one. So let us do these ones. Is this 1 to 1? Well, I can start with the graph of this function. And the graph is the famous parabola, yes? And the parabola, you see that if you draw a horizontal line which is above x-axis, it will intersect twice, so that's why this is not 1 to 1. Well, another way of seeing this is that if f of x1 is equal to f of x2, then it implies that x1 squared is equal to x2 squared. As a result of that, when you find square root, you see that, well, square root of x squared is not x. This is a fact here. Square root of a number squared is not just a, it is absolute value of that a. So here absolute value comes in, it means that it's either plus or minus of that number. Well, that means that they may have different values, but their values are the same. For example, f of 1 and f of -1 are the same. 1 and -1 are different, but they are the same. The values are the same. How about this one? F x1 is equal to f x2 implies that 2x1 plus 1 is equal to 2x2 plus 1. Ones cancel, then 2x1 is equal to 2x2. 2 cancels, and then you get x1 is equal to x2. Well, what we did was that we started from setting f of x1 equal to f of x2, and we concluded that this implies that x1 is equal to x2. So this means that this is a one-to-one function. This wasn't a one-to-one function. Well, you can do the sketch of the graph of this one. This is a line well, and it is not a horizontal line. It's not a horizontal line. That means that every horizontal line, it will intersect only once with that. For this one, e to the power x, we can do the graph. We know the graph of the function e to the power x. We actually know the graph of all exponential functions are of this form or the other direction. And then when you draw all the horizontal lines, you notice that, well, it either intersects one with this guy, or like this one intersect never, none. So, well, the definition says that, well, the horizontal uh, the horizontal line test says that it intersects with the graph at most once. So some lines may not intersect, may not have an intersection with that graph. So this is using the horizontal line test. It is yes. How about this one? Well, let's do the graph for this one too. So graph of sine x, we know how is that. So this is sine x is actually the worst possible non-one-to-one function because it is periodic, and you just see all of these horizontal lines intersect with the graph infinitely many times. And indeed, you can find values of, for example, f of 0 and f of 2 pi. These are the same things. So this is not one-to-one. How about this last one? Okay, so again, start with the f of x1 is equal to f of x2. This means that x1 plus 1 over 2x1 minus 1 is equal to x2 plus 1 over 2x2 minus 1. We have to work with this cross multiply, so x1 plus 1 times 2x2 minus 1 equals to x2 plus 1 times 2x1 minus 1. And as a result, this is 2x1 x2 minus x1 minus plus 2x2 minus 1 equals to 2x2 x1 minus x2 plus 2x1 and then minus 1. You see, this cancels with that cancels with that. Now we have several things here. You can write this. So x1, x2, we can bring these all x1s one side, so it will be minus x1 minus 2x1 equals to, take all x2s to the other side, minus x2 minus 2x2. As a result, negative 3x1 is equal to negative 3x2. And we'll cancel negative 3's, x1 is equal to x2. We started from f of x1 being equal f of x2, and we concluded that x1 needs to be equal to x2, and that is the definition for one-to-one. Okay, so this was a very quick review with some examples of why one-to-one functions are needed, what kind of issue they solve, and how we can check if a function is one-to-one or not.